This is the sun. It can kill you. We're going to give you a few tips to stay alive. Hi, my name is Matt Paiss. I'm a captain with the San Jose Fire Department. I'm currently a training captain in our training division. I'm up here doing some training on photovoltaic safety for firefighters, PV safety for short. My personal background in solar technology started back in 1982 when I worked for a company called Arco Solar, soldering solar cells together. So I've worked in manufacturing. I've also worked in the semiconductor industry in equipment manufacture maintenance. Been with San Jose for 17 years, and my own interest in this particular technology started in 2004 when I put a system on my own house and started asking the question of what do firefighters need to know when responding to a building that has a PV system on it. So a couple of the real keys to safety for photovoltaic systems are identify the system's present, notify the whole fire ground of its presence. Anytime there's light shining on the modules, they are generating electricity. You cannot turn the modules off. Nighttime operations are a bit safer, but artificial light can create a dangerous level of voltage. So just be aware that if you have artificial lights up illuminating the array, you can still have dangerous levels of voltage. Turn off the main electrical service as soon as practical. If the rescue's involved, that takes priority, but as soon as you can turn off the main service, the safer everyone will be. When you've shut off the main electrical panel, know that there is still DC power from the rooftop down to the inverter. Don't touch any of the other panels. Don't walk on them. Don't try to unplug them. Just stay away from them. Cut the hole wherever you need to if you're going to perform vertical ventilation.
PV technology produces electricity directly from the electrons freed by the interaction of sunlight with a solar panel made of semiconductor materials. The power provided is direct current, or DC electricity. The basic building block is known as a cell. When sunlight hits it, electrons are freed up. When they bounce around, that's what creates the electricity. When you wire many cells together in series, it's known as a module, and many modules put together form an array. PV systems consist of an array generating DC electricity, an inverter which changes that DC to AC and then connects to the main electrical panel and returns it to the power grid.
Sunlight hits this. Remember, one side's positive, the other side is negative. It breaks free a little electron. Electrons bounce around inside. When you put some wires on the front side and wires on the back side and put a voltmeter on it, you might get a half a volt. Well, when you wire something in series, the voltage increases. Current is going to stay the same. So what we have right here is we have a module, and let's say this is a half a volt, all right? And if I have 6 cells, what do you think this panel would produce? If each one's a half a volt, 3 volts. Excellent, all right? And let's say one cell might produce 5 to 8 amps. That's what the whole module will be rated at, and that's why I show that. All right? So when you have more cells, the voltage will increase. There's 3 different kinds of PV modules that you'll see typically. This is a tempered glass frame, aluminum frame module. This is called building integrated PV. And this one takes the place of a few of the lightweight concrete tiles. And it actually becomes the weatherproofing on top of the wood sheathing. This is a flexible laminate module. The majority of the systems, probably 98% of the PV systems installed today, are what we call grid-tied PV. You'll have the PV modules up on the roof. They create DC current. They'll be inside conduit. It'll go to a disconnect that we call a DC disconnect. And then it goes into an inverter. And the inverter's job is to make it into that sine wave, AC. Then another disconnect, and then right into the utility meter. Inverters. So these are the magic boxes. Again, their job is to take the DC electricity and turn it into AC. And how they do it is there's big capacitors inside them. And capacitors are designed to store electricity and to dump electricity very rapidly at a precise timing. Because this signal here, it's got to match the utility signal, the power coming from the utility grid before it can send power out. So it's really a magic box. There's a lot of ingenuity that goes into these inverters. But there's a lot of different kinds of inverters. We'll see some out there today. You want to have them on the shaded side because they do generate some heat. But if it's a new construction, they'll put them in the garage. They need to be in an accessible location. So that just means not a locked closet in the attic or something like that. It can be in the basement. This is another type of inverter. It's called a microinverter. And what this one's doing is this one is changing that DC electricity to AC. But it's right at the panel level. There's one of these for every solar module. And so this will take the wires from the solar module, plug right in right here. This plugs into a cable that's run along the whole rail system, and there's little boxes it plugs into. And it gets AC power because all inverters need AC power to run. Key point, you've got to have power in your neighborhood to have your solar system send it back. Commercial inverters are much larger. All right. When we talked about sizes of systems, remember I talked about this module might be 240 watts? A residential PV system might have anywhere between, let's say, 10 of these, which would make it 2,400 watts, up to 30 of these. All right, what's 30 times 240? I don't know. 10,000 watts, all right? So a residential system could be anywhere between 2,000 and 10,000 watts. And that's how much power it's making at noon on a nice clear day. Commercial, they'll be in the millions of watts, megawatts. Right? San Francisco has a really large reservoir. They've covered it with PV, 5 megawatt PV system. So we've talked about modules, inverters, conduit. These are all things you're looking for. These are all kind of red flags that you have a PV system present. So the conduit does a couple of things for us. Obviously, it protects the wire, but it also carries a ground. They might just connect the ground wire at one end of the conduit and the other end, and you actually use the conduit as a ground. So if that conduit breaks, it could be a much more dangerous situation for us. Photovoltaic system, and we'll just say PV for the rest of the day, it's much easier, it's the only electrical system that on a building that with current standards cannot be turned off by untrained personnel. So when you put it like that, okay, people start to realize, all right, this is kind of different. It's a generator. All right, PV systems are a generator. They're no different than a gas generator, a battery-backed UPS system, except it could cover quite a bit of real estate on a rooftop. And there's no on and off switch. Don't assume the power's off until verified by a qualified individual. Unfortunately, you can't call the utility. Who we have to call is people like Nick. We have to call the local contractors in our area. And hopefully, there's a sticker on the inverter that says, installed by Nick's Great Solar Company. And here's our 800 number. And we have 24-hour response. Just because somebody's an electrician doesn't mean they know solar. It's oftentimes the opposite. Because DC is very different. We wanted to see what happens when there's a compartment fire that impinges on the array, as well as a fire starting underneath the array. And one of the things that we found very surprising was the robustness of these modules. These folks do a great job of building a pretty tough module, because this one was still generating power after it had been exposed to direct flame. So what is burning when you have a solar panel burn is the plastic back sheet, the insulation around the wires. That's what's really putting off any smoke column. All right? So, but let me ask this kind of overhead question here. Is there any safe smoke? No. So every visible smoke column, and I'll even say non-visible, every smoke column has dozens of carcinogens. So that's something that we should be concerned about. Any smoke column is sheltering in place or possible evacuation. All right? These don't present any additional unique hazard when they're burning. Damaged PV systems are incredibly dangerous. Even when the fire is out, I would not go up there and touch any of that equipment. It's very important that you have electrical PPE when you're dealing with damaged PV equipment. Okay, lighting. This one here was actually pretty interesting here. I'll make it simple for you. This one here was a single 1.5 kilowatt, a 1,500 watt bulb from 50 feet away. I'm over at the array, I'm looking at the meter, and I'm seeing 340 volts on the array and 1.5 milliamps. Now, a safe level of current, but it was surprising how efficient these things are at converting light to electricity. So what's the takeaway from this one? Our artificial light will energize the array.
You'll want to secure the utilities as best as possible. Shut off the main breaker at the main electrical panel. This will shut off any AC power to inverters, shutting them off and interrupting the power that's entering the building. And remember, the DC power will still be hot from the array down to the inverter if any light is contacting the panels.
If you have a microinverter, it's working at the module level. If you turn off the AC power, this thing is off. You only have power whatever one module is putting out. So if you have 20 modules on a roof, they're all independent. Open any disconnects that you see. And again, opening means shutting them off. Don't open up the cover. So what we did was we tested several different common salvage cover materials. We took a black visqueen, one layer of it. We still got 33 volts, just light kind of getting in from the corners, but no current. All right, safe. So black works great, but you got to secure it. One gust of wind. Any tarp you really have to secure. The blue polypropylene tarps, anybody use those? It's almost full voltage and 2.1 amps. Blue polypropylene tarps do not work. These are the canvas ones, all right? They worked. 0 current, 0 amps of current. This was the interesting one. These vinyl coated, red coated salvage tarps, 124 volts at 1.8 amps. The water one, that was the biggest question that would come up, all right? So how they constructed this test was they made 2 sleds that could be slid further and closer together. For San Francisco and a couple of the few other cities that only have smoothbore nozzles, this is what they need to know. They need to stand at least 10 feet away, 20 feet away if it was going to be a higher voltage system. Once we broke that stream, just a 10-degree fog pattern, you could get less than 5 feet away from 1,000 volts. That's what we needed to hear. So up on that rooftop in Bakersfield, those guys can get less than 5 feet away, just break the stream a little bit to try and knock the arc out or put out whatever fire.
Here is a list of things not to do. Do not break a module. Don't walk on it. Do not intentionally cut into any conduit. And if there are any damaged systems, just stay away from them and do not touch them.
All right, so this is a common residential neighborhood that you might show up on. You can see on these buildings here that there are no obvious solar panels. They might be mounted on the opposite roof slope. So what's key in these situations is then the 360. So we're going to go ahead and start a 360 and look for the different components. Let's go. All right, so we're on the delta side of the structure. We've got the main meter here. However, there's not the circuit breaker panel. That looks like that's going to be inside the garage. But there's some labels here. One of them, it says warning, dual power sources. Second source is a photovoltaic system. So that says it right here for us. A lot of times these red labels will be enough for us. But the other thing that's present here is this conduit that's going into the garage that continues on. We're going to go and look for that because that's going to tell us where the array is. We see that we've got a metal conduit on the outside of the building. Goes all the way up to the roof where the array is. That's an easy one. Sometimes the conduit's inside the building. But this tells me the array is right up there on the building. I still need to find the main breaker panel because we want to secure the utilities, shut off the inverter, keeps all the power from going back inside the building. But there's always going to be power up there. Okay, so we're in the garage. We've got the main electrical panel here. The meter's right on the other side. And we have the inverter here. The inverter's job is to turn the DC, direct current electricity, that's coming from the roof, from the solar modules, turns into AC power. Goes through a little meter right here and ties into the main electrical panel. If we come in this garage and we see all this right here, the only thing we need to look for is the breaker that's powering the PV system. Now, in securing utilities, we're going to go after the main. We want to shut off everything, okay? Just remember, shutting off the main is better than turning off all of these. Preserves any evidence if you had a tripped breaker. But here is the one breaker that shuts off the inverter. So again, we shut off the main, inverter goes off. There's no power from here into the house, and all the power inside the house is off. Still power up on the roof. Okay, so this array on this house, obviously it's a small array, very visible, street side when you pull up. You can't really see where the conduit goes. That's because on this particular installation, it penetrates into the roof attic right here. All the wires come inside here. In a moment, we'll take a look inside the garage to see where the inverter is and the disconnects. But one thing I want to mention is anytime there is light on these modules, they're producing electricity. So obviously right now they are, but at nighttime, artificial scene lights will produce enough electricity to make these potentially dangerous if you were to come in contact with the wires. So one tool in the toolbox is to tarp an array. All right, let's talk about ventilation. If it hasn't become clear to you at this point, let me stress this point. Don't come in contact with the panels. If this room is the fire room, don't attempt to remove these panels to ventilate right there. You're going to have to ventilate somewhere else. So our options on ventilation now are limited because of the location of the array. We have a very narrow spot at the ridge. It's going to range anywhere from 2 to 3 feet depending on what codes are applied. But if you're going to have to ventilate in this area right here, let's say we've got the wind on this side, this is the leeward side, I encourage you to practice cutting this way, because to get a 16 square foot hole, you're going to get a 2 foot by 8 foot hole. You're going to have to roll 3 rafters, several dice cuts. It's a much more challenging hole to cut. I recommend whenever possible to cut on the other side of the roof in the normal fashion that you're trained to cut. Okay, so we're in the garage now. This is where the DC conduit comes down into the inverter. This is a little meter. It's saying how much the system's producing. Comes out as AC power into the main electrical panel. Structure fire, any other fire, we're just going to go to secure the utilities in the main electrical panel. What we see here is the main breaker. We shut off this, it shuts off all the power for the house. Best practice is to try and hit the main instead of all of them individually so you can maintain a fire investigation scene. Here's the breaker that controls the inverter. If you just want to turn off the PV system, this breaker will do that. Okay? We see that we've got some labeling here talking about that this is the PV disconnect. So this labeling is pretty good here. We don't have any labeling saying who the system installer was, who to call. That's going to be very common. But that's this system out here. Okay, we're on the rooftop of what's considered a small commercial rooftop system. As you can tell with the flat mounted roof, you wouldn't be able to see this from the street. But once we get up here, we can see that a large portion of this rooftop is covered by PV modules. There's very little room to walk around between them without contacting the metal components. So my recommendation on these kinds of systems is to stay to the perimeter of the building. These 2 boxes right here take all of the wires from all the individual strings out on the roof, and basically it's just a connection point to reduce from 8 different wires down to 2 wires that take it down to the inverter. There's no disconnects up here. There's nothing that we can do to isolate the system up here. It has some labeling that tells about the current on the system and the voltage. We can see these raceways that all the wires are in. This is good because it's keeping it up off of the roof, but there might be some sharp edges that over time could abrade the wire. Some of the commercial fires that have occurred have been in these raceways. We'd stay away from them, direct our water, try and protect the roof as best we can, but stay away from contacting the metal components with your body. All right, so here's our conduit coming down off the roof into the inverters. There's 2 inverters on this system, both identical. Comes down inside. There is a DC, direct current disconnect here. Again, this is just for servicing the system. But if we've found ourselves in this room, what we're looking for is the AC, alternating current disconnect. So as that conduit comes inside, the inverter turns into alternating current. We're looking for this. You shut it off, system shuts off. Ideally, we're looking for the main electrical disconnect for the whole building, but if you find this first and it says solar AC disconnect, that's what it does. Shuts off the inverter and there's no AC power coming out of it. Okay, here is another AC disconnect. This is the same as the ones that we were just in the room where the inverters are. This is easy for us to find because it's on the outside. All we need to do is come up, open this disconnect, and all the inverters are off. Again, we're probably going to want to shut off the power for the whole building, so let's go look at the electrical room that has the main service disconnect for the whole building. Now we're in the main electrical room for this building, and you can see all of the panels in here handling all the individual circuits within the building. You can also see there's no labeling that says photovoltaic system in here. So if this is a room that we got to first, it could be a little confusing. Go to the largest panel because we want to shut down the whole building. Here we've got an 800 amp breaker. It's a good idea to shut down the small ones first. Just go ahead and shut each of these off and then shut off the main one. That will take off the PV system. But we had found the AC disconnect outside for the PV system. So in this particular case, it's only outside. There's nothing in here for it, at least not labeled. The other thing, there's no label in here that talks about who installed the system. So if you need to contact somebody, we're going to be a little lost in this particular system. All right, so in this commercial structure here, we can see a lot of the larger conduit coming down off the roof. It helps us identify where the inverters are. If you're rolling around the building, you see that. Got a lot of combiner boxes here. Here's our inverters. DC disconnect, AC disconnect. Doesn't matter, shut the disconnects off and the inverters shut off. All right, so this view from up on the roof